All right, hello folks. Welcome back to some more beginning object-oriented programming. Today, we're really going to sort of go over a few more sort of terminology things, and then work more on our circle class, or at least look at the circle class some more, and then mess around with our rectangle class in sort of a similar way. I have a few functions to show you, a few sort of built-in things that Java allows you to do with classes, and we'll talk about a few keywords as well, a few more keywords that are related to object-oriented programming. So the first thing I want to mention today is about visibility. So you've seen some of these visibility keywords before. There's 4 visibility levels: public, private, protected, and then if you don't use a keyword, it's package private. These are modifiers that you put on your data fields and your methods, and they define what can access that data or invoke those methods. So as an example, let's say we have 2 classes. So we have class A, class B. It doesn't really matter what they are. The important part here is to note that if I have something in class B that is public, then class A can directly access it. It can access the data if the data was public, or it can invoke a method that was public. If class B has something that was private, so it has a private data variable or a private method, then class A would not be able to access it. And we are going to take a look at some of that today. We're going to see what happens when you try to access something that's private. We'll see what the error looks like. So we're going to take a closer look, particularly today, at public and private. Protected is another one. That depends on the relationship between the classes, which gets more into inheritance, which is something we'll be talking about next week. And then the sort of default visibility level, the package private, is available if the 2 classes are within the same package. I'm going to talk just a little bit about packages in just a moment, but the important thing to note here is that public is the most accessible and private is the least accessible. The rest of them depend on the relationship between the classes. A package is used as more of an organizational tool. And I have just a sort of a brief bit on them. If a class isn't explicitly put into a package, so if you as the programmer don't say that it belongs in a package, then it belongs to essentially the default package. If we have multiple packages, the only thing accessible between a class in 2 different classes in 2 different packages is the public variables and methods. Everything else is completely restricted. All right, so packages more or less let us group together classes that are related. Whenever you import something, say you import something from Java util or java.io, those are packages. So java.io is a package that contains a whole bunch of classes that are related to input and output. You can define what package your class belongs to using a package keyword at the top of your class. So something that kind of looks like this. The basic form is just package and then whatever you want the name to be. And that would be at the top of your file, usually the first thing, the first line in your file. So if I had, a bunch of shapes or something, maybe I would create a package called shapes, and then maybe I had some examples or something. So I'd shapes.examples. So Java, like I said, has lots of built-in packages like Java.io, Java util. We're going to use a whole bunch of stuff when we use Java FX in the near future. There's a whole bunch of packages that we're going to use from that. So it's an organizational thing that you can use. For this class, the stuff that we're going to work on, even the final project, packages are not necessary, but it's something that you will run across in the future. If you look at our homeworks, for example, you will see a package at the top. It's usually like edu, wit, cs, and then whatever the class is, comp 1000 or comp 1050, that sort of thing. So you will see packages as part of the homework assignments. But for now, just think of them as organizational tools for you. All right, so we'll talk about protected in the future. That's an inheritance related thing as far as visibility goes. The main thing today is going to be public and private, these 2 visibility modifiers. So far, we've essentially either been using public. So when we write our methods or something, we might have public static and then some method name, or just no visibility modifier, in which case it's sort of the default, which is the package private. We've been using sort of that for all of our data and methods. This essentially means that our data and our methods can be accessed from anywhere within our program. For package private, as long as we're in the same package, which we haven't defined any packages, so essentially we are, it's effectively public in that sense. So we've allowed everything in our class to be accessed from the outside, at least from the other code that we're writing. But think back to the principles that we talked about last time. If we use the public modifier everywhere, or the package private modifier, does that conform to abstraction in OOP? Remember what abstraction is. It's where we take this idea of this sort of complex thing happening behind the scenes, and we put a simple sort of interface over it, like a power button for the computer. Lots of complex stuff happening inside, but we have this sort of outward-facing button, which is all we have to do. We abstract all of that stuff that's happening inside to a simple button. If everything is available for another programmer or for the user to use, this is not following the abstraction principle. We're sort of breaking one of our object-oriented programming principles. So typically what you see is that the data, all of the data in your class is restricted. So we use private for the data. For our methods, we usually have a choice. Oftentimes methods will still be public, but sometimes they can be private. It depends on how you're going to use them and how you intend for sort of other classes to use them. In our blackjack game, we will see examples of both. So just as a quick example, the deck in our blackjack game, it will have the ability to shuffle the cards. But the actual shuffling method is going to be private because only the deck should be shuffling the cards, rather than anyone outside, any class outside of the deck class they shouldn't be telling the deck to shuffle. That should only happen in very certain circumstances. So there are certainly reasons to have private methods, but most of the time your methods will actually be public. So we're going to look at that when it comes to the circle right now, and then we'll mess around a little bit with our rectangle that we were programming ourselves. So here is the circle class again, but I've made a change. So I've made the radius field, the data that represents our radius, I've made that private. So it can only be accessed within the circle class itself. Outside of the circle class, essentially outside of the file that this class is in, I cannot directly access the radius. That doesn't mean it's totally hidden and I can never do anything with it. Take a look down here at the method here at the bottom. Set radius. Send in a value and it changes my radius data. So that's a way to access the data and change it through a method. And that's going to be a very common theme that you're going to see in object-oriented programming. The next question is, should our methods be private instead of public? They're public now. Should they be private instead? So let's think about what the methods actually do. We have getArea. It just does the area calculation, pi r squared. And then we have the set radius that I just mentioned. Oftentimes, these sorts of methods are meant to be used outside. If I have a circle and I want to know what the area is, say in my main program, then I should be able to access the getArea. If I can't access the radius directly, I can still sort of indirectly access the radius by computing the area. So again, oftentimes your methods will be public. They will be the things that are shown to the outside. Just like the computer example, the power button is the public method. All of the data related to how the computer actually turns on and potentially some of the methods might be private. So all we have to worry about is calling a method on and the computer turns on. The UML diagrams also change as well. So for example, we can sort of display this this private and public aspect by showing minuses and pluses. Sometimes there are also symbols if you have more of sort of a graphical sort of UML diagrams, sometimes you'll see like red circles or green squares, stuff like that, to represent the visibility as well. Typically, your constructors, and I don't have it here, but typically your constructors will be public as well. They can have a modifier too. So we'll adjust our rectangle class so that we have public constructors as well. All right, so if we go back over to main for this circle class, so for some of the code from last time, we have a bit of a problem now because our radius data is no longer public. I cannot directly access the radius outside of that class, essentially outside of that file. So this will no longer work. We're going to go into our rectangle here in just a second, and we're going to mess around with it and actually see what error it actually shows here. But we can't access this directly anymore. There's no way for us to do that. It's private. We can't access it. So one of the things you do to sort of get around this is we write a method that its whole purpose is just to return the radius. So you would say it'd be public, of course. It would return a double, and it'd be called getRadius. These kinds of functions, where their only purpose is to return a particular value that's private, or to set a value that's private, like our setRadius in the code that we had on the previous slide, those are called setters and getters. So they do have specific names. It might seem kind of weird to write these. Like, well, if you're writing these functions, it's extra code you have to write. Just make the radius public, and then you don't have to do it. Even though that might seem like a nice shortcut, the reason we might have setters and getters is that maybe we need to do something different if we say change the radius. So I'm gonna go back a slide, and we're going to look at this set radius. Let's say I had some graphics associated with this. This, I think, is sort of a good example as to why you might want particularly a set radius type of function. Let's say we had graphics associated with this as well. If I could just access the radius of my circle and change it in the class, that would just change the data. That wouldn't change the graphics at all. So I might have a circle that thinks it's a radius of 10, but the graphic maybe only shows a radius of 1 because maybe I had direct access to the radius variable. But if I had to go through a method, then the method can have more things happen. If I set the radius in the method, maybe the method changes the data, and then it updates the graphic. So doing it through a method gives me more options for what I want to do when that data changes, rather than only changing the data itself and then sort of hoping or trying to remember that I have to call other functions to update the graphics, for instance. So this gives us much more flexibility in what we do in this case when the radius changes. So you will often see setters and getters in sort of various contexts for data that is private that needs to be either accessed in some way or changed in some way in a class. All right, so let's jump over to Eclipse. And I have the rectangle open that we worked on last time. And I have main open as well. So let's think about changing the visibility here. So I've got package private for the constructor and the two data variables. So let's sort of follow that abstraction principle and let's make these private. So we're going to have private data. And we're going to use a public constructor. You might wonder, well, why would you ever not use a public constructor? That's something we'll actually look at in the future. We'll actually look at having a private constructor, which if you think about what private means, that might seem kind of weird, but it actually has some very interesting sort of effects that we can do with a private constructor. All right, and then we have our method getArea. I've saved this, so let's go back to main. And immediately what we see with the main that we wrote last time, getArea still works. Of course, we didn't change anything about its visibility, but we can't access the height and the width. We can't say r1.height and r1.width because it's now private. And the error that shows up here in Eclipse says the field rectangle.height is not visible. So it knows it's there. Eclipse knows, yes, there is a height variable. But it says it's not visible, so it's not going to let us use it. Now, this is a problem if we still want this to work. So let's write two functions. Let's write a getHeight and a getWidth. These will be public because I do want to access them from the outside. So it'll be a public double because it's going to return a double. I'm going to say getHeight. And all it's going to do is return the height. And I'll write one more. Public double getWidth. And all it's going to do is return the width. So now we're still following that abstraction principle. But we just had to write a couple of getters to make that work and change our height and width to be private. So back in main, instead of directly accessing the height and width, we want to use r1.getHeight and r1.getWidth. And now we'll get the exact same output. So exact same output as before where we left off. So that's the idea of visibility. So whenever you're writing a class, you should immediately make your data private and then make a decision about what you want for the methods. Is this method going to be called outside of this class? If it is, make it public. Otherwise, you can make it private. For me, typically, I'll make my methods all public to start with. And then if I decide later, this method probably doesn't need to be called outside this class, or maybe it shouldn't be called outside the class, then I'll switch it to private. But that should be sort of your initial sort of coding when you're creating a class. Private data, public constructor, public methods. And then you can go back and check later on. All right, so in Java, each class that you create should go in a separate file. There are ways to get around that, but that's the way that we're going to do this in this class. It is common to have a single class that has nothing in it except for main, where it's used to start the program. And that's basically what we've just done. We have a rectangle class in a separate file, and we have another class that contains main. And that's sort of how you're going to typically code your applications in Java. You may have lots of classes. So in your final project or something, you may have half a dozen classes for your project. If you're making a game or something, you might have a board class, you might have a card class, you might have like a player class. There might be a lot of files associated with your project. And this is where things like packages and stuff come in to help with organization and all of that. But this is the style that we're going to use, one class per file. And it's pretty much what you're going to see me using for the rest of the semester. I want to talk briefly about objects in memory. When we created an array, we worked on the array stuff. When we create a single array, it's all put in memory at the same time. And it's all filled in with an equivalent of 0. Right? So we had an integer array, there would be a whole bunch of zeros. Objects are very similar. So when I create a rectangle using our new rectangle, we have a little bit of data. We have the height and the width. Here I say length and width, but we have the height and width. So immediately what happens in memory, sort of underneath the hood, is that you get space for those values. Typically, they are given sort of a 0 value if you don't initialize them, but the constructor should be doing the initialization. If I created another rectangle, I would get another chunk of memory assigned with the length and the width, the height and the width from my second rectangle. And then maybe I change those values and they're set in memory. So I want you to keep this in mind. Keep it in the back of your head. You're not going to have to worry about sort of where the address of these things are. But when you create a new anything, you are allocating memory. So for objects, that's going to be all of their data. And the data can be many, many things. You could have arrays as data in your objects, in which case you would have arrays that are allocated whenever you create a new object. So keep this in the back of your head. We'll talk a little bit more about sort of memory type stuff sort of as we go on through the semester. It won't be anything super deep, but as you go on, especially if you're a CS major, as you go on, this stuff will certainly come back. For right now, we've done some printing sort of very simply, so sort of a standard sort of printing that you saw sort of all over CS1, and even for the assignments that we just had recently. And what you saw with our rectangle last time was that you can't directly print an object. Right? If I go back to Eclipse here, you saw what the print was. If I tried to print out just the rectangle, if I tried to print out just R1, it gave me that it was a rectangle at a particular memory address. It's not that useful. What if I wanted it to print this instead? What if I wanted it to print something useful? Java can do that. It does it through a particular method. We're going to mess around with writing that method here in just a second. The reason why you can't just print an object directly, or at least not in a useful way, is the JVM doesn't know what to print and how to format it. It has no idea. It knows that there's some data, you got some methods. What should I do? Should I call those methods and then print out their results? How should I format it? Where should the new lines be? All that stuff. You could write your own print method. You could write a method called print and just call the print method, and then it'll print out stuff. That will work. There's not really anything wrong with it. But Java has a particular method that you can use that will essentially do this for you. You still have to tell it what to print, but it makes it easy to print out objects. So this is called toString. You essentially create a string, and then Java does the work for you when you print the object. Typically, we're going to use a String.Format to do this. So we're going to go into the rectangle here in just a second, but I want to show you one of the sort of techniques I use to help with this. So if you want to format a string in the same way that you would use like a printf, String.Format is the way to do it. It's the exact same syntax as a printf. You just save it to a string rather than actually printing it out right away. So we're going to use this in the toString that we write in just a second. So let's go back over to rectangle. And wherever you want to put the toString is fine. Typically I'll put it near the bottom of the class because it's not typically that important. You sort of write it once and then you don't really have to worry about it again. But you can usually put it wherever you want to in the methods section. It has to look exactly like this. You have to have the exact signature correct. So it needs to be a public string called toString, no parameters. So it has to look like this. And if I'm outlining something like this, I will usually create a string called s, and then I'll return that string. Now, I'm going to fill it in here, but this at least lets me remember that, okay, I need a string and I need to return that string. It's very easy to forget to return the string here because this is not going to do the printing. You do not put a printf in here. This does not do the printing for you. You save the string, create the string, do whatever you want to with it, and then you return the string. That's how you work this. All right, so now I'm going to take s, and I'm going to set this equal to String.Format. And then I can do all the normal things I do with a printf. So I can say height and put in a percent, say 0.2f. And then I can throw a new line in if I want to. And you can sort of continue writing here if you want to. You can just continue putting stuff in. But let me just make a few separate lines, make this into a few separate lines. So I'm going to put the height here. And then I'm going to say s plus equals, because this started it, s equals this. And then I'm going to add to the string. And I'm going to take the String.Format line, and I'm going to do something similar. I'm going to say, put the width in here, and width here. And then I'll do it one more time, s plus equals, and we'll make this the area. And I'll put in get area for the method call. You don't have to write it this way. Again, you could have this all on one line. That's perfectly fine. The reason you might want to do something like this is because every time I put a new line in, I sort of make a new line in the actual code. This will show you more or less what it's going to look like on the screen. If I had it all on one line, it might be a little bit difficult to tell. But here I've taken 3 separate pieces, added them all together, and then I'm returning that S. So that's all I have to do, just something that's formatted in a way that I like. We're going to use this pretty extensively in our blackjack game. It's how we're going to be able to just print out a hand object, and then it'll print out all the information we need, all the cards the player has, the value of the hand, all of that. So it'll be some pretty cool usage of toString. All right, if we go back to main, I'm going to comment out our print lines that we were using before and just keep this one, the one that printed out the object R1, our rectangle, as a string. So the one that printed out rectangle at and then the hex number. Now I'm going to run this, and notice we get exactly what you saw in the toString. So if you write a toString, you put it in your class and you format it how you want to, you don't have to do anything else with the object except for print it as a string. So this is really, really, really useful. So this is definitely one to remember for the future. So we will certainly be making extensive use of this. All right, so back over to our presentation. I want to talk a little bit about objects as arguments. We create methods with parameters, ints, doubles, booleans, whatever, chars, whatever we need. We've seen lots of examples of that. And you can create objects that are parameters as well, like a scanner or an array or a rectangle. So you can send these objects into methods just as you would any of the other types, except remember, they are passed by reference. They're not passed by value. There is no copy of a scanner or a rectangle or something being made. It's passed by reference. So remember that means that any changes you make to the object modify the object directly, just like an array. I have a quick little sort of example code here. I'm not going to code it up. I just wanted to point out how you can go about doing that. So let me grab the annotation here. So this first piece here is a method. It has a scanner and this temperature object as parameters. And then it uses those in a specific way inside the method. It's not really important how it uses it. It's just we can take in a scanner, we can take in a temperature object. In main, down in the bottom, we create a new scanner, create a new temperature object. I haven't defined what the temperature object is or what it does, but just keep in mind that it's just an object. It's just like our rectangle. And when I call getTemperature, that's the method up here, we just send in the scanner, the name of the scanner, and the name of the temperature object. So my temperature just goes up here, gets sort of renamed to T in the method, and the keyboard input scanner goes up here and gets renamed to input in the getTemperature method. So it's not any different than using a method in a standard way. It's just the type is just different. The type is a scanner and a temperature here rather than an int and a double. So it works the same way. That's the key here. Works the same way as using regular primitives. There's a special keyword that is very common to sort of object-oriented languages. Some use a slightly different keyword for this. If you came from something like Python or something, you probably will have seen a different version of this, but they sort of all act the same way. It's this. This is a keyword in Java and lots of other object-oriented languages. Python uses self, for instance. It can be a little bit tough to talk about this keyword just because of the word itself. Just keep in mind whenever I'm talking about this keyword that I'm actually saying that's actually this being the keyword. It can be helpful to mean the current object within a class method. It's particularly useful for clarification. The thing I'm about to show you in the rectangle class, you never have to use this the way that the way that I'm going to show you. In fact, in the rectangle class right now, I've gotten away with not using this, but we can. So I'm going to show you sort of how to do that. There's another different meaning for this in Java that you can't get away with not using, but the version I'm going to show you here. If it makes sense to you, feel free to use it. I will sometimes. I'll sort of show you the situations that I might use it, but you're never required to use it this way. If it makes sense to you, sort of what it means when you first see it, that's fine. We will use it a bit later on. So let me go over to Eclipse again, and we'll jump over to Rectangle. Anywhere where I'm using height and width, instead of just saying height or width, I can put in this dot. This dot. Think of it like this. When I say this dot height, I am explicitly telling Java it is the height that is the data in this class. Now, there wasn't really any confusion here anyway. We knew the height was this height up here at the top. But say, for instance, our rectangle constructor takes in two doubles. Let's say it takes in a height and a width. So let's say it has a few parameters. If I just use height and width in here, look what happens, particularly with the highlighting. This height is corresponding to this one here, and the width is corresponding to the one that comes in. Just based on the highlighting, you can see that it's not using these, which is not what we wanted. So the way that I would write this is I would say, so I'm just going to rewrite the whole height line here. I would say this dot height equals height. And notice what the highlighting does. This dot height is the one that's up here, and the height that's down here is the one that's coming in. That's the difference here. So if you see this in a class referring to either the data or a method, for example, down here, I could say this dot get area, and it does the same thing. It explicitly says, I'm calling this get area, the get area from this class. Again, you don't have to use it because I could just use a different name here. I could just call this new height and new width. And then I wouldn't have to worry about it. I wouldn't have to have this dot height. I could just say height equals new height. And then that would work fine. If it makes sense to you as to why you might want to use it, or if it's just sort of easier to understand why if you're sort of speaking this out, you might say something like return this dot height times this dot width, for example. If it makes sense to use it, go ahead and use it. But you don't have to. You can get away with not. Again, sometimes you will see me use it. Sometimes I won't use it. It depends partially on how I'm feeling and exactly how I'm coding up some of these particular things. So it is there. You will see me use it a little bit later on this semester. We will see how it has another context in which it can be used. And that one, you will have to use it. So in this context, you don't necessarily have to. All right, one of the sort of last things for today is this idea of static versus instance. I want to start with variables because I think the variables sort of version of this makes the most sense. You've seen static variables before. You've seen static methods before as well. We're going to talk about that next. You've seen static variables, though. The error messages, for example, in the homework are static. all the data fields we've worked on in the circle class and in the rectangle class are instance variables. The reason for that is because they belong to a particular instance of the class, a particular object. I could have 100 rectangles and each one has its own version of height and width. That means height and width are instance variables. Every object has its own copy. The little sort of dumb example I have here is that every account object, if you had an object that represents, a bank account, every account has its own name and its own balance. Nobody's sharing a balance across every account or something. The alternative to this is a static data field. Every single object of the class shares a single variable. So that variable only exists in one place in memory, whereas for an instance variable, every object has its own version. A static variable is in one place in memory. That's why thinking about memory can be useful, because it sort of helps inform how the code will actually work, how the variable will actually work. So if one object, say we had a couple of rectangles, so maybe there was a static value, a static data field for my rectangle class. If one rectangle changes it, all the rectangles are going to be affected. And I'm going to show you an example right now. I'm going to do a little bit of drawing and stuff on this, but I have two classes here. I have a user class and I have just a class that contains main. The user class is relatively simple. So it has some data. So we have some regular data here. We've got a username, which should make sense, and we have an ID that is a number. So that makes sense, right? It's just every user has an ID and a username. But I also have a static int here. So this is static. It's called number of users, and right now it starts at 0. So whenever I create a user object, they all get their own username and ID, but there's only one number of users, a value, for no matter how many users I create. Notice that there's a toString, which just prints out the username, colon, and their ID. And we have the constructor that takes in a username, sets that value. And here I could use this, right? I could say this.username equals username, if that's what the parameter was. ID gets set to number of users, and I increase the number of users. So we're going to think about how that works. Let me clear out those drawings. And I'm going to draw at least the objects out here in just a second. So let's say we have a user, and the name in the code is just PJF. And I'm creating a new user called Fry. So that's going to be the username. So let's think about what happens. So I have this user called Fry, and they have a name. So it's going to be Fry. And they have an ID. So Fry's our string username, and they have an ID. Well, in the constructor, what's the ID set to? It's set to number of users, which is currently 0. Remember, number of users has data. It's a data outside. So let's say that it's in this little box right here, and it equals 0. This is our static variable, because it's not part of each object. Each object only has a string and the ID. Number of users is somewhere else in memory. So it starts out as 0. So Fry gets the ID of 0. So that's the current ID. That's the current number of users. And then, I grab my eraser, we increase number of users. Number of users goes up by 1. Awesome. So now it's 1. Now we go and we create another user called Bender. So I create another object. This one's Bender. And he's going to need an ID as well. Well, what's his ID? It's number of users. Number of users is now 1 because Fry changed it. So our ID for Bender is 1. And then we increase the number of users. So number of users is now 2. And we do the same thing. Leela gets an ID of 2. She would increase the number of users to 3. And then Zoidberg here gets an ID of 3 and would increase the number of users to 4. Of course, if we printed out all of these, we would see the name, Fry, ID, 0. Bender, ID1, and so on. So that's the idea of a static variable. It only exists in one place independent of the objects. And any object can go and change it. So that's what was happening in the constructor. We were changing that number of users to reflect, surprisingly enough, the number of users. So hopefully that sort of makes sense with these static variables, sort of what you can do with them. All right, methods can also be static. We've seen this before too. Main is public static void main. It has a similar meaning, but it's a little bit more difficult to understand than the variable version. It means that the method is shared by all instances of the class. That might sound a little weird because methods aren't like the data fields. One of the key points of static method is it cannot be used to modify instance variables directly. Because if you try to modify an instance variable in a static method, what object are you modifying? What instance are you modifying? We don't know. So you can't do it. A static method cannot modify instance variables. But static methods can be called from other methods, so like from main or something, with the class name. This is the powerful thing here. The last little bullet point here. This is the powerful piece. And you've used this before. You've actually done this before. You've used static methods. You've used the class name to call particular methods. We'll talk about where you've done that in just a second. So the next little slide here is a slight variation on those users. So we still have the same situation in our constructor here. Username changes, number of users go up, so we create all those objects, Fry, Bender, Leela, and Zoidberg. But I added a method in here. It's a static method. It's called number of users. All it does is return the number of users. So whatever this value actually is, remember it's got its little place right here. It's got its little location. And we create Fry and Bender and Leela and Zoidberg with all their different IDs based on this value. So let's say this value was 4 at the end of creating our objects. I can call this method right here. This is how I call the method. And this is the powerful piece. I don't need to use a specific instance of the object. I don't need to use PJF or BBR, or TL, or GAZ. I don't need to say PJF dot get number of users. I can use the class name itself, user dot get number of users, because it's a static method. That's the power of static methods. And again, you've used static methods before. You've called static methods. Let me go back over real quick to the rectangle class. And for our for somewhere around here, let's just do real quick a let's see. I'm trying to think of it in sort of an easy way. Let's actually go to main. And my rectangle now actually takes 2 values, so it's not too big a deal. I'll just throw something in there. And then let's think about just doing a quick math calculation. So let's say I wanted to do 5 squared or something. So we'll forget about the rectangle for a moment, and we'll just do a quick math calculation. So I need to use let's just call this results. If I want to do like 5 squared, you can just do 5 times 5, but I'm going to use something from the math library, math.pow, and I want a pow, and I'll put 5 and 2. This is a class. Math is a class in Java. Pow is a static method. Every time you've used math dot something, math.pow, add, squirt, whatever it was, whatever you used, you were using a static method. Pow is static, math is the class name. So I don't ever have to do something like this. I don't have to say math m equals new math and then say m.pow. This is not something I need to do. Because these methods are static, I can always just use the class name math, and then call those methods. So you've been using this sort of static method idea. It just probably hadn't realized it. All right, so as far as sort of the general sort of basic OOP goes, a class is a complex data type. We have our primitives, doubles, ints, booleans, chars, that sort of stuff. But a class, it's the same kind of thing, but it contains potentially multiple data fields and then methods that act on that data. And then, of course, you're going to take sort of related data and related methods, and you're going to pack them into that class. That's the encapsulation idea. There's lots of predefined classes, of course. We've been using them, since the very beginning of CS1. Things like strings and scanners. Those are all predefined classes in Java. You can define your own classes, of course. We saw that with the circle and the rectangle, and it's most often done to represent something physical in your program. We'll start working on the blackjack game next week. And you will see exactly that. You will see a card class. You will see a deck class. You will see a player class and a house class, for instance. You will see all of these different ideas of sort of physical things, players and cards and that sort of stuff. So this is just the beginning of object-oriented programming or object-oriented software development. We're getting into some of the more complicated stuff in the near future, but we'll sort of break it up with some of the GUI things. So we'll do some of the more complex OOP stuff. Then we'll get into JavaFX and how to just create some basic GUIs. Then we'll do a bit more OOP. Then we'll go back to actually having our buttons and stuff do interesting things in our GUIs. So we'll sort of break it up and sort of take it a piece at a time. For the most part, the object-oriented stuff here is going to be sort of translatable to pretty much any language you use in the future. Most languages have either very similar concepts or almost exactly the same concepts. So if you've come from another language like Python or something like that, or you've used like JavaScript in the past, and you've done object-oriented programming with them, you're going to recognize a lot of stuff here. And if you go to them in the future after you learn more Java, then you're going to recognize a lot of things there as well. So next time, we're going to continue with OOP. We're going to talk about inheritance. This is not getting a house from your parents. This is creating subclasses and superclasses. Keep working on PA2. I gave you 2 weeks for a reason. We will talk a bit about it during our sort of in-class portions and during the lab as well, because it is a particularly difficult one. Otherwise, that is all that I have for you for this one. So I will see you guys in lab this upcoming week.